Hello. This is an example of a DC nodal analysis numerical problem of level 1. So let's get started. Overlooking the circuit, looks like we have 5 total nodes, a couple current sources in there, reference node, and we're asked to compute V naught and the power generated by the current source, highlighted in gray. So the power generated across the 3 amp current source and the voltage across that same source. So let's get started. How many equations do we need to solve this? I do not see any control variables, so we're going to take the total number of nodes, subtracting the reference node, and we're going to need 4 equations for the 4 potentials listed there. Sweet. First thing I always look for is a voltage source, but I do not see one here. So we're going to use a whole lot of KCL for this problem. Let's start with V1 at the top and compute the current going across the 4 ohm resistor from V1 to V2. Using Ohm's law, we're going to get V1 minus V2 over 4. Now let's find the current going down that node across the 5 ohm resistor from V1 to V3. Ohm's law is voltage divided by resistance equals current. So it's going to be V1 minus V3 over 5. That's it for that node. Set it all to 0. Move on to node, the potential V2 on the top right here. Let's find the current going from V2 to V1 over the 4 ohm resistor. Again, using Ohm's law, get V2 minus V1 over 4. Let's find the current going across the 20 ohm resistor from V2 to V4 over the 20 ohm resistor. We get V2 minus V4 over 20. And that's it for that node. Set it all to 0. Let's move on to node V3. Here we have a current source on the left-hand side going down to the reference node. So the current source is going out of the node, and we're gonna treat that as positive. If we're going into the node, that would be negative, but it's not, so it's positive. That's just going to be 2 amps, positive 2 amps. Next, let's find the current going from V3 to V1 over the 5 ohm resistor. And again, using Ohm's law, it's going to be V3 minus V1 over 5. Next, let's go from V3 to V4 over the 8 ohm resistor. So it'll be, the current for that would be V3 minus V4 over 8. And finally, let's go from V3 down to the reference node across the 9 ohm resistor. So again, voltage, sorry, we're going to add that. Voltage divided by resistance, going to be V3 minus 0 because it's the reference node, but we can ignore that. And over 9. Set that all equal to 0. Finally, let's work with V4 potential. This one also has a current source coming out of the node of 3 amps. So let's get a 3 in there, positive 3. Let's add the current going from V4 to V3 over the 8 ohm resistor. Using Ohm's law, it would be V4 minus V3 over 8. And finally, let's add the current going from V4 to V2 over the 20 ohm resistor. So we'd get V4 minus V2 over 20. And let's set that all equal to 0. Really quick before we submit, though, to make our life easier with dealing with the matrix, personally, I like getting all the variables on one side and all of the integers on the other side. So then this third equation here, we have a positive 2. And instead of positive 2 on the left-hand side, I'm going to subtract 2 from both sides and get negative 2 on the right. Same thing here. We have a positive 3 on the left-hand side. Let's subtract 3 from both sides and get a negative 3. Now let's submit. Sweet. To solve for all these potentials, let's input a matrix. and get all these coefficients in here. So starting with the first equation, let's look at V1 first. The coefficients for V1 is going to be 1/4 plus 1/5. Is V2 mentioned here? Yes, it is. It's going to be minus 1/4. For V3, it's going to be minus 1/5. V4 isn't mentioned here, so we can leave it blank. Whoa, leave it blank. And all of that equals 0. For the second equation, V1, the coefficient for V1 is negative 1/4. For V2, we have 1/4 plus 1/20. For V3, it's not mentioned. Let's leave it blank. And for V4, we have minus 1/20. And all of that equals 0 as well. For the third equation, coefficient for V1 is minus 1/5. It's not mentioned anywhere else. Let's move on to V2. V2 is not mentioned. Let's go to V3. We have 1/5 plus 1/8 plus 1/9. And finally, V4, we have negative 1/8, 1/8. And all of that equals negative 2. And for the last equation, it doesn't look like V1 is mentioned. We're going to leave that blank. V2 is mentioned. Its coefficient is 1/20. For V3, it's negative 1/8. And finally, V4, we have 1/8 plus 1/20. And all of that equals negative 3. So let's submit that. Perfect, it solved it for us. Sweet. Submit all these values. Sweet. So now it is asking us to write the equations for the SOT variables in terms of V1, V2, V3, and V4. So let's look at V0 here. Where's it at? Oh yeah, it's the voltage across the current source. To find V0, it's going to be equal to the top potential minus the bottom potential. So in other words, it's V4 minus 0. And that's because the positive terminal is on the top, the negative is on the bottom. So V4 minus 0, in other words, just V4 is going to equal V0. So let's put V4 in there. And now let's look at the power generated. Power generated across a current source is going to be its current times the voltage of where the current is going minus the voltage that is going into the current source. So we're going to have 3 times, in parentheses, 0 minus V4. So it's going to be 3 minus negative V4, in other words, negative 3 V4. And submit those. Sweet. Now's the easy part. V0 equals V4, and we're going to numerically put in their values. We found that V4 equals negative 63.81 volts, and V0 equals V4. So let's put that in there. For power generated, we have negative 3 times V4. So it's going to be negative 3 times negative, put parentheses here just in case that gets messed up, negative 63.81. And this website is sweet. We don't really have to put this in a calculator. It'll compute it for us. And let's see if we got this right. Perfect. Quick note. For me personally, it was hard to remember all the power generated kind of formulas to find them. So I often look back on the web book where You can find everything you need to do on here, and right here it says the power generated by the current source can be found by blah blah blah. And I often have this page up while I'm doing homework. So anyway, thanks for watching, and I hope this helps.